back to my channel. We're continuing on in Chapter 5, learning about electricity and magnetism. We're on Lesson 68, and we're going to be covering pages 98 through 101. Yesterday we learned, or the last lesson we learned about static electricity, and I said there were two kinds of electricity. Today we're going to be looking at that second kind of electricity called current electricity. Now you might wonder why it's a little dark in here. I have a special little light bulb, and I have a special board behind me with some words from what we're going to read, and it's kind of like a little quiz to see if you're listening. Okay, so see if you can connect them and make the light bulb come on. I'm going to help you, of course, and but that will be at the end of our lesson. So I do apologize for the low lighting today. So let's get started. It says all electricity happens because negative charges move. And yesterday we talked about those charges, positive and negative, and those negative charges in atoms are called electrons, and only electrons move. Electrons, electricity. In static electricity, negative charges build up on one material and jump to another material all at once. This happens for brief periods of time. So what it's saying is those negative charges build up on a surface and becomes unbalanced, and when those negative charges move to the other material to balance it, it happens very quickly and the electricity stops. So it's not very useful. In current electricity, the negative charges have continuous movement through a material. So in order for electricity to be useful, it has to keep moving through a material. Energy produced by electricity can be used in many ways. It can light a light bulb or start a car engine. It can also run a computer or another machine. Current electricity can move through many types of materials. A conductor, which is one of our words up here, is a material that allows electricity to flow through it easily. Metals such as copper and silver are good conductors. However, metals are not the only conductors. Your body can also conduct electricity. That is why you need to be careful when you use electricity. Electric shocks can injure or even kill you. So, the first one we're going to talk about, we mentioned current electricity. It means that the electrons or negative charges are continuously moving through what we call a path. A path, and you need to remember that for a little bit later. But in order to have a path, we have to have something called a conductor. And usually our conductors are different kinds of metals. It mentions your book, copper and silver. Gold is also another good conductor. In fact, it's the best conductor. But we don't use gold a whole lot because it's hard to find and it's expensive. Copper, which is in this wire, you can see here, this wire, the top here, that is copper. It's a lot more easy to find copper, and it's far less expensive to use copper, and that's why it's used in most wiring. So most of your metals are good conductors and can let the energy move through it freely. I'm going to pull it up to the camera so you can see that top is copper, okay, in this wire. Now it mentions your body is a conductor, and that is very true. If you touch an electrical source and then you complete the path, that electricity will run through you and can hurt you severely or can even kill you. So it's very, very important that you have what we call, this next one, an insulator, or I'm not sure if you can see this, but here the top is exposed wire, but over top of it is what we call an insulator or plastic or a covering to protect us from the electrical shock. So let's keep going. Let's talk about insulators. Sometimes, though, electricity cannot flow through a material. An insulator, which is our word up here, is a material that does not allow electricity to flow through it easily. Wood, glass, rubber, fiberglass, and plastic are all good insulators. These things that are listed, wood, glass, rubber, plastic, things like that, this electricity cannot move through it. So people who work in wires, electricians, they cover themselves with things like rubber or plastic. The box that lifts them up to fix power lines, that is made of fiberglass. The covering in your book, the coating on these wires, that's an insulator. why we have to protect our bodies. Electricity is dangerous. It can hurt us. So we have to have insulators to protect us. Let's keep going. Whenever current electricity is moving through a wire, that wire is called a live wire, meaning it's not living, but electricity is moving through it. Touching a live wire might shock you, especially if there's no coating on it or insulator. If the shock is strong enough, it might even cause death. So a live wire is usually covered with an insulator to prevent injury. The covering is called insulation. So it's very close to the word insulator. Insulation, insulator. It's almost the same thing. Most electrical cords have plastic or rubber insulation covering the wires. So your computer cord, TV cord, you'll all see it'll usually have a black coating on it. That is insulation or an insulator. It's made of plastic or rubber to protect us from the electricity. Let's keep going. Now I said that we need a path, and I told you to remember that word. We need a path for electricity to move through it. Okay, so we're going to talk about those things. Electricity cannot flow without a power source. Okay, power needs power, and a path. A battery is an example of a power source. I have a battery sitting right here. You cannot see it very well, but it's sitting right here. A battery is an example of a power source. The power source keeps the negative charges flowing, so it's pushing those negative charges. The path must be unbroken for the negative charges to flow through. This path is called a circuit. So that's one of our words up here on my board. A circuit has to have two things for electricity to move through it. It has to have a power source or something pushing that energy, like a battery, and it has to have a path. Remember, a conductor like copper or silver. It has to have a conductor. And very, very important, that path cannot be broken. If you break that path, that electricity cannot move. Right? So it has to be an unbroken path with a power source. Path and a power source gives us a circuit. Okay, let's keep going. A circuit might have a switch. A switch is a device that is used to open or close a circuit. When the switch is open, it breaks the path. This stops the flow of electricity. When the switch is closed, the circuit is complete and the electricity can flow. Now, my lights are off in my room. So would this be an open circuit or a closed circuit? You think about it. If it's open, it's broken. If it's closed, it's complete. So is this an open circuit right now or a closed circuit? If you said an open circuit, that is correct. So I'll give you an example of a closed circuit. Hold on. See how the light changed? It's much brighter in here. Why? I closed the circuit by closing the switch. The light switch is a switch, of course, and it can open or close the circuit. So I'm going to close this. I'm going to open the circuit again, turning off the lights, and so now it's much dimmer in here. So open circuit, broken path, energy cannot move. Closed circuit, the path or the energy can move through that path very easily. Circuits can be arranged in different ways. One type of circuit connects several objects in one complete path. That's the key word. One complete path, one path. This is a series circuit. Series circuits are used inside appliances, such as television and vacuum cleaners. Most Christmas lights, the old style, are wired as series circuits, meaning one path, not circuit, I apologize. When one light bulb is removed, all the lights will go out. This happens because there's only one path for electricity to travel through. The removed bulb opens the circuit. Without a complete circuit, the electricity stops and none of the bulbs will light. So, here in your book that gives you an example, I'm going to hold it up just very quickly. See here at the bottom. That's an example of a series circuit. You have a power source and you have a path, but all of the objects are on the same path. So if this one is broken, none of the lights will work. Why? Because it broke the path, or the path is open. All right, so that's called a series circuit. And sometimes it's important to have a series circuit. But I'll explain why it's important to have the other kind of circuit in just a moment. So let's go to the last page, please. 101. Many circuits have more than one path through which electricity can travel. A circuit that has more than one path is a parallel circuit. Each object on the circuit has its own path. Most circuits in your home are parallel circuits. This allows you to turn electric objects on and off separately. For example, you can turn it on or off your radio without turning off a lamp. If one object is not working, the electricity still has a path to the other objects, okay? Now, a parallel circuit, this is much different. This gives you an example in your book. I will hold it up to the camera, okay? So a parallel circuit, you can see that there are still 3 light bulbs, but each light bulb has its own path. And a parallel circuit is 2 or more paths. This way, if one light bulb is broken, then the other light bulbs will still light up, okay? And it's important that we have parallel circuits. So think about it. In your apartment, all of the different things that use electricity, what if they were on a series circuit or on one path? You would either have to have everything on or everything off. The lights, the TV, the computer, the refrigerator, the rice cooker, the toaster, everything had to be on if it's all on a series circuit. But it's a good thing that there are parallel circuits in your apartment. That way you can turn it off and on different items in your house. Okay, so series circuit, you can think of the letter S and the letter S in singular in English. S for singular means one. Series circuit, one path. Now, parallel circuit starts with a P. In English, plural means many or 2 or more. Plural, many, parallel, 2 or more paths. Series and parallel. Now, I hope you were paying attention. I'm going to go to my little quiz to see if you're listening. So here I have conductors here in these little circles, all right? And if you guess it correctly, the light bulb will light up because I have a wire here, remember, which is our path, and I have a power source, which is our battery, and then let's see if we can get the light bulb to light up. So here we have the word silver. I'm going to touch over here. Which word would best match the word silver? Okay. Is it an insulator? Is silver one path? Is it a power source? Is it a conductor? Or is it 2 or more paths? So let's try the word insulator. Let's see if the light bulb lights up. No light bulb. How about power source and a path? No, the light bulb didn't light up. How about the word conductor? Did you see that? The little light bulb came on. Silver is a kind of conductor. Why? It's a metal. All right, let's try a parallel circuit. Parallel circuit. Remember, parallel starts with a P. And what else starts with a P? Plural, meaning more than one. So parallel circuit, is it one path? No, light bulb didn't come on. Is it power source and a path? No. How about 2 or more paths? Look, the light bulb came on. A parallel circuit is 2 or more paths. That way you can have many different things on at the same time or turn different things off. All right, how about glass? What word would best match the word glass? Is it one path? No, the light bulb didn't come on. Is it a conductor? No. Is it an insulator? Yes, it is. It's an insulator. It stops the movement of energy or stops the electrons from moving. So how about a series circuit? Can you remember the word I told you to help you remember what is a series circuit? The word singular, meaning one. How about, is it a power source and a path? No. How about one path? Oh, the light bulb came on. One path. A series circuit is one path. And then lastly, we have the word circuit. I keep saying circus. So that would be the last one, which is what? A power source and a path. And yes, the light bulb lights up. Well, I hope you enjoyed this lesson, and we will continue on learning more about electricity and magnetism in the upcoming lessons. I hope you have a great day. We'll see you next time.